Free radical.
Achha, so the question answer for this is that alkanes, they undergo free radical substitution. That's about it. Free radical substitution is this reaction which we previously did. Okay, I'll just quickly okay. Achha, so I'll just quickly go over free radical substitution. This was free radical substitution where this is electrophilic addition. Before that, I think that this is free radical substitution. What happened in free radical substitution was that the Cl radical would break into pieces homolytically, and the Cl radical would then try to bond with H, steal one of the H, form HCl, and the ethyl radical would be formed. The ethyl radical, once it's bond, it will go and bond with Cl. It would form a chloroethane, and the Cl radical would be again formed, and the process would just repeat over and over again. And the last step was the termination step, where any two random free radicals in the previous step can simply join up. The termination was that if this carbon needs a bond, the Cl needs a bond, why don't they just join up? This carbon needs a bond, the Cl needs a bond, they join up. This carbon, this carbon, they both need a short of one bond, so they would link up. So that is easy. The next one is an alkene reacts with hot concentrated acidified manganate 7 ions. And Hanji. Sorry. You unmute kar lo.
So वो मैं कह रहा था कि जो आप इलेक्ट्रोफिलिक तो आपने करवा दिया था, न्यूक्लियोफिलिक आप करेंगे?
वो मैं करा दूंगा, अभी क्वेश्चन आएगा ना, so I'll do that. ठीक है? Well, that's very simple. I'll just do that quickly. ठीक है? Achha, so this one, alkene reacts with hot concentrated acidified potassium manganate 7 to produce. Now this is strong oxidation. Okay, so this one is strong oxidation. So the alkene is undergoing strong oxidation. What happens in strong oxidation? What happens in strong oxidation is that if we go and have a look at alkenes, in alkenes you had electrophilic addition, but apart from that, there was oxidation. There were two types of oxidations. One of them was mild oxidation, where what happened was that you had a double bond, and on that double bond, the OH groups will get added. That's about it. So wherever you see a double bond, just put OH groups and remove the double bond. That was it. Now, the other one was strong oxidation. Strong oxidation was that the double bond would completely break into pieces and it will split up. It will split up into two pieces, and you would have three different scenarios. That if the double bonded carbon atom had two hydrogens, then it will turn into carbon dioxide. If it had one carbon chain, it will turn into carboxylic acid. If it had two carbon chains, it's going to turn into a ketone. So there were three scenarios, and this was an example of that. Okay, if you have a double bonded carbon atom, the double bond would break, the molecule would split at this point. And you'll focus on this carbon atom, that if this carbon has one carbon chain, it will turn into carboxylic acid. If it has, this one also has one carbon chain, so this one will also turn into carboxylic acid. So we did all these molecules that the double bond would break. One carbon chain, that will turn into carboxylic acid. If it has two carbon chains, it will turn into ketone. Two carbon chains, ketone. Now coming to this question. What happens in this case is that he's saying that this is the product. This is the product that is obtained, and you have to figure out which of the following alkenes got oxidized. So if I just zoom in and remember strong oxidation, this is strong oxidation. So the double bond is going to break in the middle. So let me just draw this molecule quickly. The molecule was that there was a double bond here, and there was this carbon chain, this carbon chain. Any changes would happen to these two carbon atoms. The double bond would break in the middle. So the double bond goes. So if this carbon has one carbon chain attached to it, the double bonded carbon has one carbon chain. One carbon chain will turn into a carboxylic acid. So this thing will turn into double bond O and OH. And similarly, this other thing would turn into, it's got 2 carbon chains. So 2 carbon chains would turn into a ketone. Okay, is that clear?
Yes, sir.
So is it the same molecule that we have? I mean, are these two the same molecule or not? That's the question now. So remember, if you look carefully, like let's start reading the molecule from left to right. So you have this carbon atom. This one over here has a carbon atom. Next carbon atom, that's a double bond O. This next one, that's a double bond O. Then you have another carbon atom, and that's where things go wrong because the other carbon atom over here has a chain. This one is just CH2. So is that clear? I mean, the first three do not match. Like if you start over here, if I say this is one carbon atom, this is the first one, they kind of are exactly the same. The second carbon atom over here and the second carbon atom over there also, they look exactly the same. But the third carbon atom and the third carbon atom over here, they're kind of different. This one has a carbon chain attached to it. This one does not. So which is why these two molecules are different. Is that clear, everyone? You clear it? Kenny? Also, is this clear?
Yes, sir.
God.
Yes, sir.
Okay, so you have to carefully look at is this molecule, because remember bent rotated versions, like if I have 3 carbon atoms in a line, there are many ways of drawing these 3 carbon atoms. I could draw it, it's still the same molecule. I could draw it like this, it's still the same molecule. So remember, bent, rotated, twisted versions are exactly the same molecule. They're not a different molecule. So they're kind of exactly the same. Now, so now the thing is, let's focus on this one, option B, because the first one is incorrect. So let's focus on option B. So I'm going to just draw this very quickly. Again, there's a double bond and there's this carbon chain, there's this carbon chain. Remember, the focus is on the double bond. These 2 carbon atoms. The double bond is going to break, strong oxidation. And once it has broken, this carbon atom has 1 carbon chain. So this will turn into a carboxylic acid, right? And this carbon atom over here has 2 carbon chains. So that will turn into a ketone. Is that clear? Okay, is this clear?
Yes, sir.
So the next part is now, is this molecule and this molecule exactly the same or are they not? So I'm going to start with this one, the first one. Is the first carbon over here matching this one? It is. Then the second one has a double bond O. So the second one over here has a double bond O. So that is exactly the same. Then the third one has a carbon chain. So the third one over here also has a carbon chain, small carbon chain. This one also has a carbon chain. Then the fourth one over there, that's a normal carbon. Then you have a fifth one. So there's a fifth one over here, right? Then you have, where did the fifth one go? I mean, this is the fifth one. Then on the sixth one, there's a carboxylic acid. You don't have a carboxylic acid on the sixth one. You have it on the seventh one, which is why these two are not exactly the same. Okay, is that clear? Because this one has 7 carbon atoms in a line. So that is also not correct. We'll try the next one then. You've got this molecule, and so there's a double bond, there's a carbon, and there's this carbon over here. I think they're kind of the same. So again, the double bond would break. So let's try and do this quickly. And this one has 1 carbon chain, so it turns into carboxylic acid. This one has 2 carbon chains, that turns into a carboxylic acid. And now start matching. The first one, 1, that's fine. 2, double bond O, that's fine. Third one has a small carbon chain. This one doesn't, so that's obviously wrong. So the last one is obviously the correct one. So if you got a double bond and there's this and this, and your double bond will break these 2 carbon atoms. So double bond goes from the middle. This turns into a ketone and this one turns into a carboxylic acid, double bond ON, OH. First carbon atom exactly the same as the one over here. Second one, that's exactly the same. Third one, it's got a small tiny branch. Then you have the fourth one that's over here. Then you have the fifth one, and then you have the sixth one, which is the carboxylic acid. So these two are exactly the same. Is that clear? So the answer is option D.
सर
Yes.
सर आपको पता कैसे चलता है कि लाइक कहाँ से स्टार्ट करना है, कहाँ पे लाइक एंड तो पता चल जाता है, लेकिन स्टार्ट लाइक कौन से कार्बन से करना है स्ट्रक्चर के अंदर?
अच्छा वो मतलब खुद देख लो ना कि let's say carboxylic acid, match something. This end has carboxylic acid, right? So you could either start from this end, like this one has carboxylic acid. So let's say that's the first one, right? मतलब एक एंड मैच कर लो ना, उसके बाद फिर कंटिन्यू करते रहो. समझ आई बात?
यस
तो मतलब इस केस में I'm starting from that side क्योंकि I know कि there's this एक side there's a carbon, so I'm starting at that side and so I'm starting at that side and we continuing from that side. Okay, so this one exactly matches, but you have to be careful. I mean, this is slightly difficult because you have to remember that a molecule can be drawn in a bent way, but it would be still the same molecule. Okay, because the connections are exactly the same. So और क्या कोई question था?
सर
हाँ.
सर आप कह रहे थे कि प्रेसिडेंस ग्रुप से स्टार्ट करना होता है?
नहीं वो तो नेमिंग वगैरह ना, we're not naming this. ठीक है, मतलब नेमिंग अगर करनी, ये मैं काउंटिंग गुस्सा नहीं कर रहा, मैं आई एम जस्ट ट्राइंग टू मैच दिस. हम उसको नेम नहीं कर रहे. नेम अगर करना होता वी वुड हैव स्टार्टेड फ्रॉम दिस साइड. ठीक है, इज दैट क्लियर?
यस
अच्छा, so the next thing is okay, we've got what's the next one? Next question. अच्छा, the next question is about a halogenoalkane. ठीक है, it's about a halogenoalkane. So let's quickly first very quickly go through halogenoalkanes. We did that. We did halogenoalkanes. अभी किए थे कहाँ है? Cracking and combustion. 1 second. I think before that. So this one, yes. Just a second. That's carbocations. I think we did do this one. We did do halogenoalkanes, this one. So halogenoalkanes, I told you that you have halogenoalkanes. Halogenoalkanes have a Cl, and there are three main substitution reactions which are known as nucleophilic substitution reactions. What happens is that when you have a halogen in a carbon chain, what happens is that actually I have some notes which are really good. I'll share those notes. पहले मैं दिखा देता हूँ थोड़ा सा, just a second. It's just 5 pages of organic. That pretty much sums it up. 1 second. If I have, so it's like a division chart with the mechanisms. So it's this one. This is basically the whole of organic chemistry in one chart, which you have to memorize. Plus, I think this one also has the mechanisms as well. Okay, the mechanisms are, remember halogenoalkanes. Let's just use this for a second. Where do you see halogenoalkanes? Is there this one? So remember, halogenoalkanes over here have 3 nucleophilic substitution reactions. Like if you have a halogen, the halogen can be replaced by OH -1. It will turn into an alcohol. So the chart goes to an alcohol. It has a CN. If you put a CN, it turns into a nitrile. And if you have NH3, it turns into an amine. So halogenoalkanes undergo 3 nucleophilic substitution reactions, which are given over here. So OH, NH2, and CN. Now, what we learned about this was that you had to learn the mechanism as well. So we did discuss the mechanism. And the mechanism for this was that you had 3 types of halogenoalkanes: primary, secondary, and tertiary. The primary ones, their reaction mechanism was this, that the primary ones, the nucleophile OH -1, NH3, or CN -1 would attack the carbon positive directly. And it will go and directly bond with the carbon atom and the Cl would leave. So it's like the OH approaching and the Cl trying to leave. So it was a one-step reaction and everything happened in one go. Now, if you look at this question, the question that was in the paper, this one, where's the paper? If you look at this question, now this is clearly a two-step reaction. I mean, first one thing is formed and then there's another thing that is forming. So it's a two-step reaction. So what happens is primary halogenoalkanes don't have two steps. They have just one step. This thing happens in one go. That's it. If the OH minus one is coming in, it will come and push the Cl away and that's it. The alcohol would be formed. Tertiary halogenoalkanes were two-step reactions. What would happen in tertiary halogenoalkanes was that in the first step, the Cl would leave. And in the next step, the OH minus one would come in. So it was first a carbocation was formed, the Cl would leave, and the carbon would become electron deficient. So there was a carbocation intermediate. So that was step number one. And then the OH minus one would come in. So he's basically talking about a tertiary halogenoalkane. And that's what the question is about. So he's saying which point in the diagram is correctly identified. So there's going to be a carbocation at Y. So there's definitely going to be a carbocation, which is going to be C. The answer is going to be C because why it's going to be C? Because it's a two-step reaction. I mean, the graph is a two-step reaction. First, one thing is formed, and then the next thing is you form one thing, and then you form the next thing. So that happens in tertiary halogenoalkanes. Cl leaves first, forms a carbocation, and in the next step, the OH minus one comes in and forms the alcohol. Yes.
So step one is X, yeah?
This is X, right? There is no X in this case.
Then if it's
I mean, this one, there is no X in this case. It's a carbocation getting formed, right?
Then what's happening at X?
In that case, it's probably the beer leaving. Like the beer would leave first, right? So somewhere over here, the beer is leaving, and it would then, and the carbocation would be formed, right? And then the OH minus one would come in, and it would join with this carbon and form the alcohol.
Okay.
So, हाँ जी.
सर वो प्राइमरी के अंदर क्या होगा वो स्पेस एक्सटेंड कर सकते हैं?
The primary was simple. In the primary, it was a one-step reaction. There was no two-step. In primary, you had this thing. Okay, the OH minus one would come in and attack the carbon, and the Cl will get knocked out. Negative ion आया ना, so negative ion is going to come in and will try to bond with this carbon. The electrons over here will get repelled by the OH minus one. So the Cl would leave. Clear? तो प्राइमरी सिंपल था. प्राइमरी में था कि OH आता था और Cl निकल जाता था साइड से. मतलब OH आता था, वो Cl gets pushed away. ठीक है? तो it all happened in one go. It was a one-step reaction. Tertiary के अंदर it did not happen in one go. पहले the Cl would leave, form a carbocation, carbon would be short of one bond, फिर OH minus one आता है. Clear है? बहुत थोड़ा सा difference है, लेकिन there's this difference. उसमें everything happens in one step. Everything happens in one go. This happens in two steps. ठीक है? Is that clear? और उसकी रिजॉन क्लियर है और उसकी हमने रीजन भी पढ़ी थी. We did learn कि what's the reason for that. We learned that that when you have a primary halogenoalkane, the primary halogenoalkane में the carbocation is very unstable. Why? Because the carbon in a primary halogenoalkane, the carbon has a very large positive charge. Why does it have a large positive charge? Because it's not surrounded by large groups. It doesn't have a lot of electrons surrounding it. So the carbon has a pretty strong positive charge. So it doesn't let the Cl go away. So the Cl stays with it until the OH minus one comes in and pushes the Cl out. Tertiary में क्या होता था? Tertiary के अंदर the carbocation was easier to form. It was a lot more stable carbocation. Why? Because if the Cl leaves, the carbon gets a positive charge, but the positive charge is going to be very small. Why is it going to be small? Because it's surrounded by large groups. Number 27 electrons around it. ठीक है? So if there's a lot of electrons around it, the positive charge would be neutralized or it will be very small. So it doesn't attract the Cl-1 as such. So it's a lot easier to form the carbocation. So the Cl would leave early. In a tertiary carbocations are easier to form. Primary carbocations are not easier to form because if the Cl tries to leave, the positive charge is really big because it's not surrounded by a lot of electrons. Okay, so that was the reasoning. We did the reasoning as well. ठीक है, और पेपर के अंदर जो आपने लिखना था वो सिर्फ ये था कि fewer electron donating alkyl chains in primary halogenoalkanes, hence carbocation formed is unstable, and there's a higher positive charge density, so it's not going to form. As anyways, coming back to the question, 1 second. So coming back to the question, that's the answer to this one. Next one is bromoethane and chloroethane are added separately to water. Hydrolysis reaction occurs. Which compound hydrolyzes more rapidly, and what is the mechanism? So we do know that it's nucleophilic substitution because we just did that. So we did nucleophilic substitution. Okay, so it's about the same. It's about the same SN1 SN2 reaction. Why is this a nucleophile? Because OH-1 is attracted to positive charge. Anything that's attracted to positive charge, that's a nucleophile.
Sir,
हाँ जी.
sir, एक question है.
हाँ पूछो.
So अगर for example कार्बन के साथ like सारे हाइड्रोजन बॉन्डेड है ना, तो उस केस में तो कार्बन तो partially नेगेटिव होगा, तो इस केस में तो OH तो फिर बाइंड नहीं कर सकता ना?
नहीं, पार्शियल नेगेटिव क्यों होगा? अगर सारे हाइड्रोजन होंगे.
Yes.
नहीं, फिर तो उसके ऊपर मैं I'm just saying कि if all of them are hydrogen, think of this as primary. ठीक है? कि it would be very hard for the Cl to leave. Okay, let's assume the Cl tries to leave, right? The Cl takes the electron, becomes a negative ion, right? Let's assume the Cl has left, taking the electrons with it. So Cl becomes -1 and the carbon becomes positively charged. तो मुझे तो ये positive charge क्या होगा? ज़्यादा होगा, कम होगा?
Slight positive.
नहीं, लेकिन अब तो ये full carbocation बन गया ना, it's a positively charged ion. लेकिन is it going to be a large positive charge? Is it surrounded by electrons or not?
Yes.
नहीं, कोई इतने electrons तो नहीं है. एक electron, ठीक है. It's not really surrounded by a lot of electrons. Like if you have a look at वो जो हमने यहाँ पे किया था, कि अगर alkyl chains होंगी, तो कार्बन CH3 यहाँ पे होगा, CH3 होगा, इधर भी CH3 होगा. So that's 9, 9, 9, 9. That's 27 electrons around it. तो समझ आइए, वो उसके अंदर तो इलेक्ट्रॉन्स कोई खास है ही नहीं, उसके पास तो सिर्फ 3 इलेक्ट्रॉन्स इर्द गिर्द है. तो मतलब the positive charge, तो यहाँ पे the positive charge is going to be really small. तो फिर it will allow the Cl to leave, क्योंकि it can find electrons from other places, but it's surrounded by electrons. So it doesn't need Cl's electrons, so it will allow the Cl to go away. Okay, so in this case, that's the main difference. Okay, primary carbocations are harder to form. Tertiary carbocations are a lot easier to form, and that is why the mechanisms are different. In tertiary halogenoalkanes, the Cl leaves and a carbocation is formed, and the carbocation is very stable, so that is actually formed in the reaction, and then the OH-1 comes in. But in primary, the carbocation is harder to form. It's very hard for the Cl to leave because the positive charge is really strong. So the Cl stays attracted to the carbon until the OH-1 comes in and knocks out the Cl. Okay, so everything happens in one step. Anyways, coming to the next question. This one is, which halogenoalkane will rapidly hydrolyze? So the reactivity of halogenoalkanes depends on this thing. We must have written about the reactivity. If you haven't, so this thing, remember, I'll just add reactivity. Now remember, the reactivity of halogenoalkanes depends on the strength of the carbon and the halogen bond. So not this one. The least reactive would be fluorine. I mean, let's say these are all hydrogen atoms. So that's the least reactive. Then you have Cl, which is slightly more reactive. And then you have carbon with bromine, which is going to be even more reactive. And then you have carbon with iodine, that is going to be the most reactive. Why? Because why is the reactivity increasing? Because it's so reactivity increases. And why is it increasing? It's easier to break bonds of bigger atoms. Why? Because you have bigger atoms always form weaker bonds. When you have bigger atoms, there's less orbital overlap. So there's less orbital overlap and there's a longer bond length. So it's a lot easier to break bonds in bigger atoms. The iodine would break very easily. The fluorine bond would be very strong, so it's a lot harder to break. So when you have these substitution reactions, bigger atoms, their bonds would break very easily. When you have, I mean, if you imagine if you have a fluorine over here, the carbon fluorine bond is really strong, so it's a lot harder to break. Is that clear?
Yes.
So compound that hydrolyzes more rapidly, that's going to be bromoethane. So it's going to be B. Chloroethane would have a stronger bond. So the answer for that is B. The next one is about it's about Hanji.
Sir, वो hydrolysis सिर्फ वो nucleophilic के केस में होगा ना?
Hydrolysis is a reaction with water. So I mean, when you use the word hydrolysis, remember there's only one of them which is called hydrolysis, which is the one with OH ions. Okay, the other ones are not called I mean, they're all nucleophilic substitution, but the other ones are not called hydrolysis. Okay. So next one is there's a compound and you have to find the empirical formula. That's kind of easy if you can quickly do this. It's how do you find empirical formula? Oxygen is 36.36 and you've got hydrogen, which is 9.10. So you divide this by 12, divide this by 16, divide this by 1. And if you do that, what do you get? And you can try this. Does it even have a calculator with them?
So, sir, carbon के लिए आ रहा है 4.545.
That's a 4.545. What's the next one?
Oxygen के लिए आ रहा है 2.2725.
That's a 2.27. Last here, 9.1, right? So you're going to divide everything by 2.2725. Divide by the smallest. And this would be 2.2725. So I think you're going to get 2 and 1 and 4. So the empirical formula is C2O1. O is 1. And H, I think, is 4.
Yes, sir, exactly.
So now, so what is the mass of this empirical formula? That's 12, 12, that's 24, 24 plus 16 is 40. So this is 44. And they're saying that the MR is coming out to be, 88. So that means the number of atoms in the actual molecule are twice this. I mean, empirical formula gives you the ratio of the atoms. So the actual formula would be C4, O would be 2, and H would be 8. Okay, that's going to be your actual formula. And they are asking for an alcohol. So you can just go and have a look at which one has 4 carbon atoms. So that's 1, 2, 3, 4. And so we are getting 2 oxygens. Now there's one problem over here. which is, okay, why are we getting 2 oxygens? None of the answers has 2 oxygens. Did we do this correctly? I said, sorry, the compound, the question is slightly more tricky. It's not that simple. The question is that the alcohol is oxidized to form compound Y. So let's assume this is compound Y. So the alcohol is getting oxidized. So this thing is the formula of the product of oxidation. Is that clear?
Yes.
So this is not the alcohol, this is Y. So we're going to one by one try and see which one would get oxidized. What type of alcohol is this one? It's 1, 2, 3, and 4 carbon atoms. So if I draw A, so that's 1, 2, 3, and 4 carbon atoms, and there's an OH on the third one. I say, is this a primary, secondary, or tertiary alcohol? What type of alcohol is this?
Secondary.
Okay, so that's a secondary alcohol. So if it's a secondary alcohol, where's our oxidation of alcohols? So if this is a secondary alcohol, it's what do secondary alcohols get oxidized to? This part.
Ketones.
Okay, so secondary alcohols, where's our ketones? Just a second. This one. Secondary alcohols, they get oxidized to ketones. So it's going to turn into a ketone. So this thing over here will turn into double bond O. Now let's try and figure out, do we have the same formula, which is, yes.
सर ये प्राइमरी सेकेंडरी और टर्शियरी अल्कोहल को लाइक डिफरेंशिएट करने का आपने कोई बताया था लाइक उसका कोई होता है?
हाँ तो वही कार्बन चेंज ना कि OH है ना, मिलता है कि अल्फा कार्बन जो है, how many carbon chains are attached to this? 2 है ना?
एक कार्बन तो 2 है
तो secondary है, that's secondary, ठीक है. Halogenoalkanes में भी you had primary, secondary, and tertiary, right? So alpha carbon would be attached to 1 carbon chain, that's primary, 2 carbon chains, that's secondary, 3 carbon chains, that's. Actually, anyways, that can't be the answer, because the formula that you're getting for Y has 2 oxygens. So it can't be a ketone. What about the next one? What about B? Let's just quickly draw the skeletal formula of B. That's 1, 2, 3, 4, 5 carbon atoms. So that is also incorrect, because if you oxidize a 5 carbon atom thing, you're going to get a 5 carbon atom thing. Your formula has 4 carbon atoms. Is that clear? It can't be B. What about this one? This one is 4 carbon atoms. That's 1, 2, 3, and 4. And the last one has OH. Is this a primary alcohol or secondary or tertiary? Which one is this?
Primary.
So primary alcohols, they turn into carboxylic acid. So it turns into serial bond O. This carbon atom over here turns into serial bond O and OH. So is this the product Y? So how many carbons it's got? It's got 4 carbon atoms. How many hydrogens? This one will have 3. This one will have 2. This one over here will have 2. So that's 2 and 2, 4 plus 3, that's 7. 7 plus 1, 8. So you're getting 8 hydrogens and you're getting 2 oxygens. So that's exactly the answer. So the answer to this one is C. Okay, is that clear?
Yes.
Yes.
सर
हाँ जी.
सर लेकिन यहाँ पे एक ऑक्सीजन शो कर रहा है.
नहीं, 2 ऑक्सीजन है ना. एक ही है. वो प्राइमरी अल्कोहल था ना, तो वो it turned into carboxylic acid. Serial bond O and OH हो गया. Well, previously it was just C with OH. Now it's serial bond O and OH. ठीक है?
Yes.
So remember this. Remember the chart. This chart is very important. That secondary alcohols, they turn into ketones and they get oxidized using KNO4, K2Cr27, and ketones can be reduced back to a secondary alcohol. And the same applies to primary alcohols. They turn into aldehydes and then they get oxidized to carboxylic acids and they can be reduced back into primary alcohols. So the next question, Yagla wala, that's about, I think that's about reduction with NaBH4. So what will happen over here? You got a ketone or an aldehyde, it will get reduced back. Like if you have an aldehyde, it turns back into an alcohol. If you have, similarly, if you have a ketone, it gets reduced back into a alcohol. So all you have to do is turn this back into alcohol. That's it. So aldehyde ketones, they turn back into. So it's the reverse. This over here is a reducing agent. So it's kind of the reverse of the previous reaction. So the answer to this one is going to be, it's going to be the first one. It's going to be A. Is that clear?
Yes.
सर
हाँ.
सर कैसे होगा?
नहीं, वही है कि अगर कीटोन होगा वो क्या होगा? अगर वो NaBH4 डालोगे, it's going to turn back into an alcohol. मतलब वो जो alpha carbon, that's a ketone that turns back into an alcohol. If you have a carboxylic acid, it turns back into an aldehyde. If you have an aldehyde, it turns back into an alcohol. Both of them, but the alpha carbon turns back into an alcohol. So I just did that. I had an aldehyde, so I just turned it back into an alcohol. I had a ketone, I turned it back into an alcohol. That's it. ठीक है?
अच्छा, तो वो reducing agent की बात कर रहा था.
हाँ, क्योंकि NaBH4, I know that's a reducing agent. Anyways, next one. Next one is a compound Q shows the following reactions. It gives an orange precipitate with 2,4-dinitrophenyl hydrazine. So let's just quickly do 2,4-dinitrophenyl hydrazine since it's not there in the notes. Just a second. So what is 2,4-dinitrophenyl hydrazine? और इसको ना मतलब aldehyde का section बना लेते हैं. वहाँ पे I'll just add carbonyl compounds. So starting with the first one, this is a test for identification of. So it's used as a test for identifying aldehyde and ketones. So let's just quickly do all the reactions of aldehydes and ketones, carbonyl compounds, just very quickly. They don't have a lot of reactions. So the main one, the first one, is 2,4-DNPH, and this is specifically for carbonyl compounds. So what happens is you've got carbonyl compounds. Carbonyl compounds are two compounds. One of them is an aldehyde. The other one is a ketone. So an aldehyde is C-double bond O at the end of the chain, and ketone is C-double bond O in the middle of the chain. So aldehyde and ketone. Now the first thing is identification, which is 2,4-DNPH. With 2,4-dinitrophenyl hydrazine.
सर ये क्या इसका reagent होगा?
हाँ, ये इसका reagent है टेस्ट करने के लिए, ठीक है? अच्छा, it is also known as 2,4-DNPH, just 2,4. So it's known as comma होता है, ठीक है? Number और number के बीच में there's a. So it's also known as 2,4-DNPH. So it's a test for identifying, gives a orange precipitate, sorry. So this one gives an orange precipitate with aldehydes and ketones. And sometimes, very rarely, they also ask for the equation or the formula of this thing. Now the equation is, this is what happens. Like if you have an aldehyde, let's say there's a ketone, C-double bond O. Now what 2,4-DNPH is, it's this molecule. It's N with, it's a hydrazine. Hydrazine is 2N with, it's like ammonia with 2 nitrogens. And there's a benzene ring. So you got a benzene ring. And you've got 2 NO2 and 4 NO2. So remember, you should be able to identify, most of the time it's just 2,4-D in pH. Most of the time, you don't need the formulas. You just need that the test for identification of carbonyl compounds is 2,4-D in pH, and you get an orange precipitate with aldehydes and ketones. Very rarely, they might, instead of saying 2,4-D in pH, they might actually show you this thing. So remember, don't get confused. This is 2,4-D in pH. So they might give you a question and they might ask for the test and they'll just not mention 2,4-D in pH. Instead, they'll give the formula. And the formula could be a structural formula as well. They might just simply write NH2, NH, and then there is, I think, C6 and H3 and 2 NO2s. So that's the condensed formula of this. And what happens is that the reaction is, it's a condensation reaction that the water molecule gets, it gets removed. So the water molecules, they get removed and the molecules, the two molecules, they join up, resulting in this thing. So the two molecules, they join up. In the middle, the water gets produced. And this molecule joins up with this molecule over here. And it's a condensation reaction. A water molecule is produced as a byproduct. So, I mean, you can leave the reaction on choice because it's very rare. I mean, they do actually ask, but very rarely they ask for the equation. Most of the time, it's just what is 2,4-D in pH? It's a test for identifying aldehydes and ketones. What happens when the test happens? You get an orange precipitate with aldehydes and ketones. ये इसके अंदर भी दिया होगा ये जो chart. Where's my chart? Just a second. Somewhere in aldehydes and ketones, this would be. Yep. Most of the time, you just need to know this. If you have ketones and aldehydes, you add 2,4-D in pH, and you get an orange precipitate. That's about it. But if you have the capacity, make sure you remember the reaction as well, because it has been asked. Anyways, the question is about the first part of the question. Go back to the question. Where's the question? The first part, it gives an orange precipitate with 2,4-D in pH. What does this tell us? It tells us that this thing is either an aldehyde or a ketone. Is that clear?
Yes.
And the second part is it gives a red-brown precipitate with Felling's reagent. So where did you learn about Felling's reagent? Felling's reagent was oxidation of alcohols. So Felling's reagent was over here. That remember, aldehydes, they do get oxidized with toluenes and with Felling's. With Felling, they give you a brick red precipitate is formed. So aldehydes, they do get oxidized, but ketones don't. Like ketones, if you heat them with K2Cr27, they're still stuck at ketones. There's no further oxidation. So there's this major difference between aldehyde and ketones, and that is, I mean, the next step is always, once you identify a carbonyl compound, the next step is always, what do you do? How do you differentiate between the two? So the difference between aldehydes and ketones is one of them gets oxidized, the other doesn't. So difference between an aldehyde and ketone. So aldehydes get oxidized and ketones don't.
सर
हाँ.
सर अपने जो फिलिंग रीजन शो करे ये तभी यूज हुआ था ना कि जब एल्डिहाइड टू कार्बोक्सिलिक जाता है बाकी लाइक पिछले वाले में नहीं होता फर्स्ट स्टेप में.
हाँ. So and ketones they don't. So that's the major difference between. So when you're trying to identify an aldehyde or a ketone, the first step is you react it with 2,4-D in pH. If you get an orange precipitate, that's an aldehyde or a ketone. Then to differentiate between the two, one of them gets oxidized, the other one does not. तो ये बल्कि साथ ही बना हुआ है. ये जो दो थे ना एक्स्ट्रा, ये तो थे खाली aldehyde के लिए. Toluenes and Felling. Brick red precipitate, इसके अंदर you get a silver mirror. Anyways, come back to the question. So that means this is an aldehyde, not a ketone. मतलब ये वाला टेस्ट जो है ना, ये कंफर्म कर रहा है कि it's a aldehyde. Clear?
Yes.
Acha, so
Yes,
how
sir.
many aldehydes? So that means the alcohol is out of the question. The propanone is also out of the question. The next part is that you get a yellow precipitate with alkaline aqueous iodine. This is known as the iodoform test. So that one is known as the iodoform test. So let's do the iodoform test also in the same aldehyde ketone box. Okay, what's the iodoform test? ये इसके अंदर दिया हुआ होगा iodoform test, ये जो किधर गया हमारा division chart. The iodoform test right at the bottom, this one. So I'll just explain it over here. The iodoform test is a test. The test is NaOH aqueous plus iodine. You get a yellow precipitate. It's a test for identifying these two specific structures. Specifically, these two structures. It's either a CH3 next to a acetyl bond O, or it's a CH3 next to a COH and alcohol. But it has to be exactly this structure. And what happens is कि जब आप उसको NaOH and I2 के साथ react करते हो, the CH3 part breaks away and it ends up forming CHI3. और जो बाकी part है ना, that turns into a carboxylic acid, a salt of the carboxylic acid, because the conditions are alkaline, so the carboxylic acid would react with it. So every time this would happen. So अभी तक हमने इस question को, if you're trying to answer this question, we were at this point that that we knew that it was an aldehyde. So is it ethanol? Ethanol is this thing. Like if I draw ethanol, ethanol is CH3 and C double bond O and H. And propanone is this thing. Sorry, propanol, not propanone, क्योंकि वो it's an aldehyde. वो तो पहले हम काट कर चुके हैं. Propanol. Propanol is this thing. It's CH3, another CH2, and propanol, 3 carbon atoms. Third one, there's a double bond OH. Now you're getting a positive iodoform test. So that means, what does that mean? Okay, if you get a positive iodoform test, the iodoform test is specifically for a methyl group that's next to acetyl bond O. Okay, that's when the methyl will break away and form CHI3, which is a yellow precipitate. So it's specifically for this methyl with acetyl bond O. So किस वाले में there's a methyl next to acetyl bond O. This is a methyl next to acetyl bond O. Over here, the methyl is not next to acetyl bond O. So this one will not, it will not give a iodoform test. This one will give an iodoform test, a positive result. The CH3 will break. ठीक है, the CH3 will break away and form a CHI3 yellow precipitate, और वो जो दूसरा part है ना, that will turn into a carboxylic acid. ठीक है, is that clear? Iodoform test.
Sir?
हाँ.
Yes.
सर ये आइडोफॉर्म टेस्ट में सिर्फ लाइक सारे अल्काइल्स में सिर्फ लाइक एक मिथाइल ही लाइक होना चाहिए ना, बाकी तो नहीं होने चाहिए.
मतलब iodoform test is not a test for a functional group. वो exact इस structure का test है कि अगर methyl is right next to acetyl bond O, then the test would be positive. Clear? तो
yes,
और exactly CH3 होना चाहिए कुछ भी, और अगर methyl is next to a carbon with an OH and an H, तब भी test positive होगा. ठीक है, so it's not for any alcohol, exactly ये structure होना चाहिए. Then the CH3 will break apart and it will form a yellow precipitate of CHI3. So anyways, this one is कहाँ गया हमारा paper? It's so we have figured out that the correct one is ethanol A. ठीक है. So you got next one. You've got a sample of tartaric acid reacts with an excess of LiLH4. तो इसका हमने क्या पढ़ा था कि carboxylic acid होगा तो वो OH पे convert हो जाएगा, aldehyde होगा तो वो भी, to form the organic product J. So let's draw this molecule. It's how many carbons? 1, 2, 3, and 4. So that's 1, 2, 3, and 4. अच्छा, ends पे, इस end पे भी carboxylic acid है, that end is also carboxylic acid. So this is carboxylic acid. This end is also carboxylic acid. अच्छा बीच में क्या है? This carbon has an OH, this carbon also has an OH. तो OH भी attached है. So there's an OH, this one also has an OH. अच्छा, this is the molecule. What did I tell you about LLH4? If you see a carboxylic acid, it will turn back into an alcohol. ये कहा था ना? So this carbon atom,
Yes.
अच्छा, this carbon atom will turn back into an alcohol. ठीक है, तो OH हो गया. And the same with this carboxylic acid. This carbon atom will turn back into, so it's going to turn back into an alcohol. ठीक है, तो उसके साथ दोबारा alcohol आ जाएगा. अच्छा, so he's saying what happens when NOH is added to separate samples of tartaric acid and J. So this is your J. तो पहले तो tartaric acid, NOH remember carboxylic acid के साथ react करेगा. It's going to react with carboxylic acid. So only tartaric acid. Alcohols don't react with carboxylic acids. Remember that. Alcohols are not acidic. So only tartaric acid reacts. Not this one. Alcohols don't have any reactions with bases. Is that clear?
Yes.
Sir?
So what is tartaric acid?
I mean, it's this one, tartaric acid, this one.
Okay, okay.
ठीक है?
Sir, I have a question.
Yes.
Sir, so aldehydes oxidize to give carboxylic acid, right?
Yeah.
So if carboxylic acid is reduced, shouldn't it give aldehyde first?
It should give aldehydes first, but he's using excess. So let's assume that it did not turn into an alcohol. It turned into an aldehyde.
Yeah.
So even then, it's still not going to react with NOH because aldehydes are not acidic.
Yeah, okay.
ठीक है?
I just wanted to. So if there was no excess, then it would become an aldehyde.
But even let's assume we're not sure that if it's turning into कहाँ पे वो? Let's assume we're not sure that if it's going all the way to a primary alcohol.
Yeah.
ठीक है? Let's assume that it's turning into an aldehyde, and so even then the answer would still be B.
Yeah, okay.
ठीक है? So in this case, it doesn't really matter if it's turning back into an aldehyde or if it's turning back into an alcohol. So ये कर लेते जल्दी से.
Because sir, for different questions, what should we do? Aldehyde or
if he had said excess of LiLH4, then it's obviously going to be primary alcohol. Like the reaction is going all the way.
okay.
ठीक है, so it's going all the way. And actually, last one, जल्दी से कर लेते हैं. You have got an alcohol. I'll just draw the skeletal formula. That's 1 carbon, 2 carbon, 3 carbon, 4 carbon. So that's 1, 2, 3, 4. The end one is a carboxylic acid, right? And the first one over here has an alcohol, OH group. And there's a double bond between the middle carbon atoms, right? So he's saying it forms a cyclic compound. So you've got an alcohol and you've got a carboxylic acid. So what will happen is that these 4 carbon atoms would, the molecule would 1, 2, 3, and let's say 4. So the molecule would become, he's saying the molecule becomes a cyclic compound. So let's just draw this in a sort of twisted way. This one had carboxylic acid, and this end over here had alcohol, right? Both of these are the same molecules. Is that clear? There's no difference between the two. Is this clear?
Yes, sir.
So what happens when you have a carboxylic acid, when you have an alcohol, they end up forming an ester. The OH is lost and the H is lost from the neighboring carbon atom, and they end up forming an ester. So
this reaction, it doesn't need alcohol and a carboxylic acid separately. It can be on the same chain.
Because we're assuming that because the molecule is becoming cyclic. So that means this end is joining up with this end. That's the only way the molecule is becoming cyclic, right?
Yeah, okay.
So, and there's a double bond as well. Like, the middle 2 carbon atom had a double bond. I forgot to add that. So which one is the correct option? Is this, you would have to, let's talk about, let's say this is 1. So this is 1. Then you have an oxygen. So that's number 2. This is number 2. Then you have a third carbon atom. That's number 3. So you have number 3. Then you have number 4. That one has double bond, right? And then you have number 5. So I think this one exactly looks like this one. Is that clear? I mean, I started off with the carbon making double bond, that's 1. Then you have an oxygen next door, that's number 2. So that's oxygen number 2. Then you have number 3 right next door to oxygen, that's number 3. Then number 4, number 5. So everything exactly matches out. So I think that's option number C is the correct option. Is that clear?
Yes.
Yes, sir.
ठीक है, चलो ठीक है, let's continue tomorrow then, ठीक है?
So,
हाँ जी,
sir, वो Monday का lecture.
तो मैं करता हूँ, ठीक है?
Okay, sir.
ओके, अल्लाह हाफिज़।
चले सर, अल्लाह हाफिज़।
Right, sir. Assalamu alaikum.
अस्सलाम।